example that Professor Deep used in yesterday's class, there was also a stock C that was thrown into the mix, and this stock has a payoff that looks like this. Now, one thing that you have to be a little bit careful of is that this is the payoff, not the price. Okay, watch out for this. This is the payoff, not the price. I'll explain in a minute why that's important to realize. This is not similar to what you have down here. This is the payoff that you get in the good state of the world and the bad state of the world. And the question really is this: what should be the arbitrage-free price for stock C? In other words, what should be the arbitrage-free price for stock C? Okay, next let's set up the replicating portfolio pretty much as we did previously. I have the synthetic portfolio here, and this synthetic portfolio is made up of what stocks? Stocks A and B. Okay, so this is the synthetic portfolio made up of stocks A and B down here, and we have stock C here. Okay, what is the payoff of stock C according to the problem? If state 1 of the world occurs, 120, and if state 2 of the world occurs, it is 70. Okay. Now what do we know? We know that we want to create this synthetic portfolio whose payoff in both the good state and the bad state will be equal to what's going on with regard to stock C. So you need to set up something on the left-hand side which will equal the right-hand side payoff of stock C. The same thing in the bad state of the world. Okay? How do you go about setting that up? Tell me the numbers. For stock A, if the good state of the world occurs, the price is 30 multiplied by QA, that's right, plus 18 times QB. For this, it's going to be 10 QA plus 12 QB. Go ahead and solve this. Tell me what you come up with. Guys, synthetic portfolio value for A is how many shares of A? 1 share. Here? 5. Obvious, right? It's a matter of just solving the equation simultaneously. And of course, you can easily confirm that that picking 1 share of stock A and 5 shares of stock stock B does replicate the payoff structure on stock C. For instance, 30 times 1 is 30, plus 18 times 5 is 90, 90 plus 30 is 120. So you have replicated the payoff on stock C by picking 1 share of A and 5 shares of B. 10 times 1 is 10, plus 12 times 5 is 60, 60 plus 10 is 70. You have replicated the payoff on stock C in the bad state of the world. Now, however, the problem down here is a little bit different from the previous one, because what we are really asking down here is, what should be the price of stock C, given the fact that you can clone stock C from using stock A and stock B. So we want to figure out the implied price for stock C from using this relationship down here. How do I do that? I know that I can kind of create stock C in a sort of a backdoor kind of fashion. Now let me give you a real world example of why this kind of thing is important, because a lot of this seems very theoretical, okay? A few years ago, I was working for an organization I was consulting for an organization that was going to issue a new type of bond called a convertible bond. Now, this bond had never been issued before, so there was no market price. So the fundamental question that the organization was asking is, what should be the price of this convertible bond? Since it has never been priced before, we had to come up with some backdoor way of pricing this convertible bond. Here is what we recognize about the convertible bond. And it's not like a great insight, but here's what you can do with regard to a convertible bond. A convertible bond is a bond that gives you the option of converting the bond into shares of common stock. So in fact, what you can do is you can decompose the convertible bond into two parts. One part of the convertible bond is exactly like any other bond. It's a straight bond component. The second part of the convertible bond is actually pretty much like a call option. So the manner in which we figured out the value of this convertible bond was, this bond was being priced in the market, so we knew the price of this bond. The option for this company also was being priced in the market, so we knew this value. So we managed to create this convertible bond using the bond and the call option, and we were able to price it that way. That's exactly what we are trying to do down here. We are trying to say, if I can create stock C from using stock A and stock B, what should be the implied price for stock C, given that I've been able to clone stock C from stock A and stock B? Now, given that you're able to clone stock C from using 1 share of stock A and 5 shares of stock B, what should be the price for stock C? What do you guys think? It should be 1 share of stock A multiplied by the price of stock A, which is how much? Which is 15, that's right. This is the current price, plus 5 shares multiplied by the price of stock B, which is equal to 12, which is the price that was derived in the handout. 15 plus 60 is equal to, that's the price in the handout, $75. Now the question is, here is the arbitrage aspect of the pricing down here. Now, the price we said is equal to $75. Okay? Now, we want to show that this is an equilibrium price. In other words, if the price was not $75, you should be able to make risk-free profits, right? And we know that risk-free profits is incompatible in any sort of efficient market. So what we have said is the theoretically correct price, the arbitrage-free price for stock C is $75. Now let's make an argument by contradiction. Let's say, suppose the price of stock C is not $75, but is in fact $100. What we can then show is that if the price is not 75 but 100, we should be able to make risk-free profits. Okay? So let's do it this way. Let's suppose price of stock C is not 75 but 100. The answer to the question is yes, of course, and it's actually a fairly obvious answer, but this is something so important that it's worth elucidating this explicitly. What do I do? If the price of stock C is not 75, but stock C is actually trading for 100, how can I make a profit down here? You guys are getting tied up with this long shot thing too much. Don't worry about this long shot. It's actually a very simple idea. What can I do? So which stock do I sell? Yeah, buy what do I buy? I buy 1 share of stock A, buy 5 shares of stock B for what price? For $75. So basically what I'm doing is this: buy 1 share of stock A for how much? For 15. Buy how many shares? 5 shares of stock B for total price 75. Total price is 75, right? That's right. So what I've done basically is this. I have bought different pieces. Okay, so I bought 1 share of stock A, 5 shares of stock B. What do? I put it together and I make stock C, right? I buy 1 share of stock A, I buy 5 shares of stock B, piece it together, fuse it together, and I create my stock C. How much did I pay for this synthetic security that I created? I paid $75. How much can I now sell it for? That's right. You can actually, in fact, let me address that question. You guys are always hung up on reality. You know, everything down here, down here can be done. With stocks, it's actually a difficult example to do this with stocks, but you can actually do this with bonds, for instance. The classic example of this with bonds is something called coupon stripping and bond reconstitution. The example that I'm talking about down here is an example of actually bond reconstitution. What you can basically do is this. You can buy 2 small packages of bonds, fuse it together, and then sell it in the market as one big bond. In fact, this kind of a bond is called a coupon strip, and this kind of procedure that I'm highlighting down here is called reconstitution. Essentially what you're doing is you realize that the sum of the parts is less than the whole. So what you do is you buy the parts, fuse it together, make a whole, and sell the whole at a higher price. In fact, by the same process of argumentation down here, you can show that even if the price of the stock is $76, you make a $1 arbitrage profit. So the price must collapse to 75. If it is lesser than 75, you can use a reverse argument from here, basically what is called stripping, to show, for instance, that you can again end up with 75. The basic idea down here is that the only price that is consistent with an arbitrage-free profits price is $75. A higher price will lead to profits. A lower price than 75 will also lead to profits. So the only price that is consistent with an efficient market is 75.